everybody. My name is Rebecca Zerlin. I'm a graduate research assistant out of Texas A&M University of Kingsville and the Cesar Claiborne Wildlife Research Institute. I'll be talking to you today about the effects of prescribed burning on butterfly populations in South Texas. I like to begin by giving out the statistic that about 1 out of every 3 bites of food we take is due to pollinators, and that includes 75% of our major agricultural crops. So many of the foods that we eat, such as apples, berries, cashews, I know there's a lot of coffee lovers out there, those are all crops that require pollination. And our pollinators can provide billions of dollars of ecosystem services worldwide per year. So they're pretty important to keep around. Over 99% of pollinators are insects, such as butterflies or bees, and over 67% of flowering plants require our insects as pollinators. So they're kind of a big deal. With that said, recent studies have shown declines in insect populations, such as this study out of Germany in 2017 that saw a 76% population decrease of flying arthropods over a 27-year period. There have been other studies that have come out saying that they're also seeing declines in insect populations. So that brings us to the next point of, well, what do we do now? We should look for ways to help conserve insect pollinators. One such method is the use of prescribed burning. I know I don't really have to talk too much about the benefits of burning here at the Fire Congress, but we'll talk about how they're important to butterflies. Butterflies have a very specific life cycle pattern. As larvae or caterpillars, they require certain host plants. So for example, many people are familiar with monarch butterflies requiring milkweed. A lot of those host plants are forbs, so burning can help encourage the forb growth from the seed bank once vegetation has been removed due to a burn. It also can increase nutrients. In the first round of funding for this study, we saw that protein content in grass after a burn went from about 4 or 5% on average to 15% after burning on average. And it stayed elevated for more than 90 days post-burn. So we see that burning can provide that increase of nutrients, and we know that butterflies and caterpillars, they do like to have the freshest growth for their offspring to eat. So that's a benefit of burning for butterflies as well. And all around, we know that burning can promote plant growth. Some species require smoke or fire in order to germinate or grow. Those are our benefits for prescribed burning on butterflies. The purpose of this study is to determine the effects of prescribed burning on butterflies here in South Texas. My study site is located on the East Foundation's El Sal's Ranch, which is a 27,000 acre that are located in Willacy and Kennedy counties of Texas. So right down here, you can see my clicker or my little mouse. The East Foundation was established from the estate of Robert C. East in 2007, and its mission is to support wildlife conservation and other public benefits of ranching and private land stewardship. The mission is achieved through research, education, and outreach. El Sal's Ranch, we see about, on average, rainfall about 23 inches, sometimes more, like in the case of this past year. We'll talk about the burn type a little bit. We do burn in both winter and summer. Here are the average temps, relative humidity, and wind speed for each of the seasons. Our burning and ignition black lines are ignited with strip flanking fires or backfires, where our Gulf cordgrass is present. Our main pastures are burned with head fires. Here's a little graphic of what it looks like. Okay, so this is a rangeland burn, so we don't have many trees, but we like to show it off because we think it's pretty cool. A fun video of that. And here's some aerial views of some of the burns for our plots. So, all right. And that's what it looks like post-burn, or once things have finished up, before and after. Okay, so we'll talk about the treatments for this plot. Our study is a CRD factorial +1 with repeated measures. At our field site, we have 16 plots that are burned with different season, so winter and summer, and different time return intervals. And these time return intervals are short term with about 2 or 3 years between burns, and long term, which is 5 or more years. We also have non-burn control plots as well. And here is a map of all of our different plots, how big they are, and their different burn treatments. In each plot, we have placed 4 belt transects that are 100 meters long to form a square. And these are going to be walking transects. So we do monthly walking surveys to identify all butterflies located within 5 meters on each side of our transect. The butterflies are identified down to species if possible. We also identify any interactions they're having with the plot, what they're doing, such as flying, patrolling, nectaring, resting, etc., and so forth. Extra transects are placed in cordgrass dominated plant communities, especially along the coast. In this area, we do have some both cordgrass dominated plant communities. We wanted to see if there is a difference between that and just our non-cordgrass dominated plant communities. So an extra transect array was placed in these areas and are walked as well. So as I said before, we go out every month. We survey these 24 different transects for butterflies and vegetation as well. So there are 6 butterfly families. Each of our butterflies observed was sorted into their respective family. We organized all this information by month. So we were able to separate a family per month and plot, and everything was totaled up to get the abundance. So using ArcGIS, we did interpolation using the topo to raster tool. This created a point elevation map, which creates a hotspot map as seen over here in the bottom left corner. And we could get the monthly butterfly abundance totals and see kind of what were the hotspots. For all of my maps, the darker the color, so reds mean a higher abundance, lighter greens mean a lower abundance. So here's just an example of what it would look like for a month. We then used a raster calculator and we added the different months and family maps to determine hotspots throughout the year. This was also done for the grand total of all butterfly species, but we have it broken down through season, family as well. So this is just what it comes out, our end result looks like. And for year 1, from March of 2020 through March of 2021, this is our grand yearly hotspot total, all butterflies that were observed through the year. We do see some areas where we're seeing a lot more butterfly abundance, especially over here in plot 15, seems to be a great spot if you're a butterfly. But looking at all of these plots together, we don't see one certain treatment that really stands out, but we do get a feel for some stuff to look at once we break things down a little more. Here this is broken down into seasons, so spring, summer, fall, and winter. You'll notice in the winter months, we do see more warmer colors along the coast, which could be due to the temperature being warmer there, or there could be a difference in nectar availability in those areas. We do have some vegetation data that we will be examining in the future regarding that. And here we have our yearly family hotspots. So the previous maps I just showed where all of those families were added together for total abundance. This is broken down into those 6 families. We're seeing if there's maybe a difference in the different families in terms of reacting to a certain burn treatment or time return interval. And this is what that looks like. We didn't once again see anything overall in terms of families and certain treatments, but we did see some interesting spots to look at regarding individual families. So Pieridae, which is one of our families, which includes your sulfurs, your whites, your yellows. For folks that aren't big butterfly people, those little yellow butterflies you see flying everywhere, that is a Pieridae, that is a sulfur of some kind. What we did notice is that we're seeing a higher abundance near these little green areas, and these green areas are our cordgrass dominated transects. So there's something over here that we're really seeing that they seem to really enjoy. Over here, we do have a lot of cordgrass in these transects, even though they weren't specifically cordgrass dominated transects. So that's a pretty interesting thing to note. On the other hand, the nymphalidae, which are your brush-footed butterflies, these include your monarch butterflies, painted ladies, buckeyes, snouts. We kind of saw a little bit on the opposite side of things. So we're seeing more of these hotspots in these purple transects, or in these purple locations. And that means that there's something in the non-cordgrass dominated areas that's really appealing to them. So overall, we didn't see a treatment effect on butterfly abundance. And that's okay. You know, we go out once a month and we're just doing our abundance count. So let's take a look at species richness. So this is our butterfly species richness for all treatments for year one of the study. Once again, that's March 2020 through March of 2021. We're going to break this down into later slides, but we noticed that all the families seem to follow a similar trend once the cooler months begin in October. Some of our slides are going to have this little SS with arrows at the bottom. That is just when we did summer short burns. So keep that in mind for the future slides. Here we have looking at winter versus summer and species richness. In our summer short, you do notice a bit of a drop right after burns, which is to be expected as much of the vegetation is burned up and not available for use. But we don't really see anything that stands out too much in terms of trends for our winter versus summer here. And here we have our long versus short time return interval. Once again, this is when our burns were happening. We did see a drop in our summer short when those burns happened right after. And that's what we have there. So early results look like long interval burning may support more butterflies than the control treatments in the spring months. Short interval winter burns happened immediately before our project started in February of 2020, and short interval summer burns happened during the project, so it's hard to see any possible positive impact from them at this stage. So we have one more graph we're going to show. So what we see down here is season and time return interval acted independently of each other in their effects on family richness. So because of this, we can look at the main effects of season of burn and the main effect of time return interval. So upper left here, richness did not differ between season of burn, whether the control was included. So we didn't see a difference whether they were burned in summer or winter or not burned at all. However, a return interval does have an effect on family richness. The a priori comparison between the long and short intervals showed that richness was reduced by these shorter intervals. When compared short versus long, we had a p-value of 0.0246, which is seen in this graph as well. So we are seeing that the more often you burn, it is going to have an effect on family richness. And we will be seeing more of this, hopefully, once we get year 2 data, which will be collected we should be finished collecting in 2022, early 2022. So just a couple of things to consider. Once again, these are early results. This was only for year 1 of the study. We're still collecting year 2. Year 2, we do expect to see some differences, especially having some heavy rainfall and some very cold snaps that we've seen over the past year. So we do expect to see a difference in results in year 2. Looking at diversity versus abundance, diversity appears to be impacted more than abundance, which was seen in our graphs and our tables. And our entire ranch, just one thing to consider is this entire ranch could be a potential ideal management plan in terms of burning for butterflies and other arthropods. Literature has shown that when you're burning an area, you want to make sure that you have areas that aren't burned that can act as refugia for insects. We see that with our control plots. It's also recommended to burn at different times throughout the year at different return intervals. And we see that with our different treatments and plots that are being burned. We could have results, but this could just be such a great ideal management plan with our ranch that it's really easy for butterflies from other plots or other parts of the ranch that are able to go in and recolonize uh, the ranch or the plots as well. So lastly, I would just like to make some acknowledgements to our funders, East Foundation, Barrientos Scholarship Fund, Plant Scholarship Fund, the South Texas Quail Coalition, the Association for Fire Ecology, Cesar Claybrook Wildlife Research Institute for helping to fund this project. Thank you to my advisor and committee, Dr. Rideout, Dr. Wester, Dr. Patrock, and all of the wonderful techs and volunteers and helpers that have helped with our field work and our burning and the monthly waking up at 6 a.m. to go count butterflies and chase them in the field with a net and feel like children again. So because this is recorded, I am not here live to take questions. I will leave my email right here at the bottom. If you do have any questions, please don't hesitate to reach out to me. I will also have my Whova account, so please feel free to send me a message on there. And with that, thank you so much for listening to my talk today. I really appreciate it.